Today we are going to discuss about some problems related to head loss due to friction. Please note down the problem. Find the head loss due to friction in a pipe of diameter 300 mm. Diameter 300 mm and length 50 meters. Length 50 meters, through which water is flowing at a velocity of 3 meter per second. At a velocity of 3 meter per second. Using Darcy's formula and Siggy's formula. In case of Siggy's formula, C equal to constant value, C equal to 60. Right? Find the head loss due to friction in a pipe of diameter 300 mm and length 50 mm through which water is flowing at a velocity of 3 meter per second using Darcy's formula and Siggy's formula. Siggy's constant C is equal to 60 and kinematic viscosity is given, that is equal to 0.01 Stokes. They want to determine the head loss due to friction in case of Darcy's equation and also head loss due to friction in case of Siggy's formula. Right here, for the determination of head loss due to friction in Darcy's formula, we know one standard formula, that is HF, head loss due to friction. HF is equal to 4FLV square by 2GD. This is the standard formula. Here 4 is the numerical value, okay, no problem. Length of the pipe, here they have given length of the pipe, this is also no problem. And velocity is also given in our problem, that is 3 meter per second, and 2 is numerical value. G is nothing but G is equal to 9.81. Right? And diameter D is also given in this problem. This is also have, only unknown is F. For the determination of head loss due to friction, first we are going to determine the friction coefficient of friction. For the determination of coefficient of friction, we have two formulas, that is depends on the Reynolds number. Coefficient of friction F is equal to 16 divided by Reynolds number power 1 by 4 if Reynolds number is less than 2000. Reynolds number is less than 2000. Coefficient of friction F is equal to 16 divided by R. And another case, F is equal to 0.079 divided by Reynolds number power 4 if Reynolds number is more than or in between 4000 to 10 power 6. If the Reynolds number value is 4000 to 10 power 6, we are going to determine the coefficient of friction by using this formula. If the Reynolds number is less than 2000, we are going to determine the friction factor by using this formula, that is 16 divided by R. For that, first we are going to determine the Reynolds number. We know Reynolds number formula RE is equal to rho VD by mu. Here rho is the density of the water, V is the velocity of flow, D is the diameter of the pipeline, mu is the viscosity of the fluid. But in this problem, they have given kinematic viscosity. Kinematic viscosity is equal to 0.01 Stokes. Right? For that, this formula can be written as VD by nu, that is the kinematic viscosity. Since kinematic viscosity is equal to mu by rho. Therefore, in place of mu by rho, we have taken kinematic viscosity. Therefore, substitute the values here. Velocity of the flow in the pipeline that is given 3 meter per second. 3 meter per second into diameter. What is the diameter? Diameter is equal to 300 mm. That is equal to 0.3 meters. 0.3 meters. 0.3 meters divided by kinematic viscosity is given. Kinematic viscosity is equal to 0.01 Stokes. So first this converts into SI system. First this is the CGS system. First this kinematic viscosity value converts into SI system. Therefore kinematic viscosity equal to 0.01 into 10 power minus 4 meter square per second. These are the units of the kinematic viscosity in SI system. In CGS system, Stokes are the units of the kinematic viscosity. Therefore, kinematic viscosity equal to 0.01 into 10 power minus 4 meter square per second. Right? Therefore, here 0.01 into 10 power minus 4. Then Reynolds number Re is equal to Re 3 into 0.3 divided by 0.01 into 10 power minus 4. This value Reynolds number Re is equal to 9 into 10 power 6. This is the value of the Reynolds number. There is no units because the Reynolds number is the dimensionless parameter. Right? The Reynolds number is equal to 9 into 10 power minus 6 means the Reynolds number value is more than 2000 and also that is more than 4000. That is in between the 4000 and 10 power 6. Therefore, the friction factor is determined. Therefore, the coefficient of friction F is determined by using the formula that is equal to 0.079 divided by Re power 1 by 4. That is equal to 0.079 divided, what is the Reynolds number? 9 into 10 power 6 whole power 1 by 4. This is equal to, friction factor is equal to 0.00256. 0.00256. This is the friction factor. Now we have the friction factor value. So for the determination of head loss due to friction, 4FLV square by 2GD. This is the standard formula. Here F is the coefficient of friction. This coefficient of friction is determined here. Coefficient of friction F is equal to 0.079 divided by Re power 1 by 4. That is equal to 0.079 divided by 9 into 10 power 6 whole power 1 by 4. That is equal to 0.00256. This is the coefficient of friction. Now we are going to determine the head loss due to friction. Head loss due to friction HF is equal to, head loss due to friction HF is equal to 4FLV square by 2GD. 4 F is determined here, coefficient of friction. Right? L is given in our problem. Right? Finally, head loss due to friction HF is equal to, head loss due to friction HF is equal to 4 into 4 F. What is the F value? Coefficient of friction 0.00256 4 FL. What is the length of the pipe? That is 50 meters into 50 into 4FLV square. What is the velocity? 3 meter per second. That is equal to 3 square divided by 2. G value 9.81 into diameter is equal to 300 mm. That is equal to 0.3 meters. Finally, head loss due to friction by using Darcy's formula, HF is equal to 0.782 meters. In this problem, they asked that what is the head loss due to friction by using the Darcy's formula. Now we have determined head loss due to friction from the Darcy's formula, that is 0.782 meters. And also find the head loss due to friction by using Ceggi's formula. Using Ceggi's formula. What is Ceggi's formula? Velocity V equal to C root mi. Ceggi's formula, V equal to C root mi, where V is the velocity of flow, C is the Ceggi's constant, m is the hydraulic mean depth, I is the slope. Now velocity of flow that is given, that is equal to 3 meter per second. Velocity of flow V equal to 3 meter per second given, and constant C value, Cg's constant is also given in the problem, that is equal to 60. And hydraulic mean depth M is nothing but hydraulic mean depth or hydraulic radius. M is equal to D by 4. M is equal to D by 4. Here diameter of the pipe is given, that is 0.3 meters. So 0.3 divided by 4. This is also known to us. This is also known to us. Hydraulic mean depth is also known to us. And I is equal to, they have given one formula. I is nothing but slope, hydraulic gradient. I is equal to HF by L. Hydraulic gradient I is equal to hydraulic gradient line, or hydraulic gradient I is equal to HF by L. Therefore, I is equal to HF is the unknown divided by L. Length of the pipe is given, that is 50 meters. Now we are going to substitute these values in the equation. Finally, we have the head loss due to friction in the pipe by using the Cg's formula. Right, V is equal to how much? 3 meter per second. V is equal to 3 meter per second equal to C. C is nothing but 60 root. M is nothing but D by 4. D is nothing but 0.3 divided by 4 into I is nothing but HF by L, that is equal to HF divided by 50. Right, only unknown is HF in this equation. Therefore, head loss due to friction HF is equal to 1.665 meters. Head loss due to friction HF is equal to 1.665. This is the data they have asked in this problem. Right, very clear? Right. Now we are going to solve one more problem related to head loss due to friction, that is the major loss in the pipe flow. Right, please note down the problem. Find the diameter of the pipe of length 2000 meters. When the rate of flow of water through the pipe is 200 liter per second. Rate of flow of water Q is equal to 200 liters per second. And the head loss due to friction is 4 meters. HF is given, that is equal to 4 meters. Take the value of C, that is Cg's constant, that is 50. Right. This is the given data. Based on this data, we are going to determine the diameter of the pipe. D is equal to how much? Right? So here they have given Cg's constant, that is equal to 50. Now we are going to use the formula, Cg's formula, for the determination of the diameter of the pipe. Once again, the length of the pipe given, that is 2000 meters. Discharge flowing through the pipe is also given, that is 200 liters per second. And head loss due to friction, that is given 4 meters. So, and also C value, that is the constant, Cg's constant given, that is equal to 50. And finally, we are going to determine the diameter of the pipe D. Right? So, Cg's constant they have given. Based on that Cg's constant, we have one formula, that is equal to V is equal to C root Mi. Right? Now we are going to determine the diameter of the pipe D. But velocity is given, velocity is not given. C is given, Cg's coefficient given. M is nothing but hydraulic mean depth. Hydraulic mean depth M is equal to D by 4. So that M is also not given. And I is nothing but hydraulic gradient line. But from this equation, I is equal to, we know one formula, that is equal to HF divided by L. Right? this is equal to, what is the HF? Head loss due to friction, that is given in the problem, 4 divided by, what is the length? Length equal to 2000 meters, right? I is also known to us. For the determination of diameter of the pipe, we are going to use the formula, Siggy's formula, V is equal to C root Mi. In this formula, velocity is unknown and also hydraulic mean depth D is also unknown. First, we are going to determine the, what is the velocity, how to determine the velocity from the given data. We know one standard formula, discharge Q is equal to AV, cross-sectional area into velocity. Therefore, velocity V is equal to, we are going to determine the velocity V. Therefore, V is equal to Q by A. Right? What is Q? Q is given, that is 200 liters per second, but that converts into meter cube per second. Right? Q is equal to 200 liters per second. That is equal to 200 into 10 power minus 3 meter cube per second, right? The given discharge Q, that is liter per second, that is converted into meter cube per second, that is equal to 200 into 10 power minus 3 meter cube per second, right? Therefore, Q is equal to 200 into 10 power minus 3 divided by area. What is the area? Diameter is given? No, diameter is not given in this case. So now area formula, area of the pipe or area is equal to pi d square by 4, where d is the dia of pipe. Let d is the dia of pipe. Therefore, area is equal to pi d square by 4. This is equal to 4 into 200 into 10 power minus 3 divided by pi d square. This is the velocity, right? Velocity. Right, now we are going to substitute the values in the standard equation. In the standard equation, V is equal to C root Mi. What is the velocity? Velocity is equal, this is the value, that is equal to 4 into 200 into 10 power minus 3 divided by pi d square. D is the diameter of the pipeline. That is equal to, what is the C value? C value is given in the problem, that is equal to 50 square root of M, hydraulic mean depth M. Hydraulic mean depth M is equal to D by 2. This is equal to, hydraulic mean depth M is equal to D by 4. This is equal to D by 4 into I is equal to, we know one standard formula, HF divided by L, head loss due to friction divided by L, head loss due to friction given in the problem. Length of the pipeline is also given in the problem, that is 2000 meters. Therefore, I is equal to 4 divided by 2000. Finally, we are going to determine the diameter of the pipeline. Only unknown is diameter. From this equation, finally we have determined the diameter of the pipe is that is equal to 0.557 meters. 0.557 meters. Only one technique here. I am going to repeat the problem. In the problem, they have given length of the pipe is 2000 meters. Discharge is given 200 liters per second. That converts into 2000. That converts into 200 into 10 power minus 3 meter cube per second. And head loss due to friction, that is equal to 4 meters. And C value given 50. Find the diameter of the pipeline. Let the diameter of the pipe is small d. Now we are going to use the one formula, that is the standard formula, Siggy's formula. V is equal to C root Mi. In this formula, V is not given directly. They have given discharge. By using the discharge, we are going to determine the velocity. Discharge Q is equal to AV, that is the standard formula. Then V is equal to Q by A. Q is equal to 200 into 10 power minus 3 meter cube per second, that is the discharge. And also for the determination of area is not given here directly. For the determination of area, formula is equal to pi d square by 4, where d is the diameter of the pipe. From this equation we have 4 into 2000, 4 into 200 into 10 power minus 3 divided by pi d square. Now this is the value of V. Now this value V is substituted in the main equation. Main equation V is equal to C root Mi. V is nothing but 4 into 2000 into 10 power minus 3 divided by pi d square is equal to C is nothing but 50, that is given in the problem. M is equal to hydraulic mean depth, that is equal to D by 4 in circular section. Right, and I is equal to HF by L. HF is given 4 meters, L is given the 2000 meters. In this equation, only unknown is diameter of the pipe. Diameter of the pipe. Finally, we have determined diameter of the pipe. D is equal to 0.557 meters. Right. Now we are going to solve one more problem related to head loss due to friction by using the Sigis formula. Now we are going to discuss about one more problem. First, note down the problem. An oil of specific gravity is 0.9 and viscosity is 0.06 poise is flowing through a pipe of diameter 200 mm. Dia is given, that is equal to 200 mm at a rate of 60 liters per second. Q is also given, 60 liters per second. Find the head loss due to friction. What is HF? For a 500 meters long pipe, L is given, that is equal to 500 meters. 500 meters. Find the power required to maintain this flow, and also they need the power required to maintain this flow. Right? This is the given data. Here in this problem they have given specific gravity 0.9, viscosity given, that is 0.06 poise, diameter of the pipe given, that is 200 mm, that is equal to 0.2 meters, and discharge given Q is equal to 60 liters per second, that is equal to 60 into 10 power minus 3 meter cube per second. And find the head loss due to friction HF, and length of the pipe given 500 meters, and also determine the power required. What is power? What is head loss due to friction? Right, based on the given data, we are going to use one formula, that is HF is equal to 4FL V square by 2GD. This is also as like as earlier problem, but here what is the difference? In case of earlier, that is the first problem, they have given kinematic viscosity, but in this problem they have given viscosity. That is the difference. And also here they have asked one more problem, that is the what is the power required to maintain this flow. These two are the difference. So remaining all points are whatever we have discussed in the first problem. Same steps we are going to follow here also. Right, HF is equal to 4FL V square by 2GD. Here 4 is known to us. Right, F is not given in this problem. Right, length of the pipe is also given in the problem. And velocity is not given. Velocity is not given, but we are going to determine the velocity by using the discharge. Discharge is given in this problem. 2 is okay, no problem. G is equal to 9.81. D is diameter of the pipe, that is given 200 mm, that is equal to 0.2 meters. In this case, only two unknowns. One is the coefficient of friction, another one is the velocity. First we are going to determine these two heads, then these values are substituted in this equation. Finally we have the head loss due to friction. Right. Here for the determination of friction, coefficient of friction, F is equal to 16 by Re if Reynolds number value is less than 2000. Another condition, another formula, F is equal to 0.079 divided by Re power 1 by 4. If Re is more than 4000 or Re is in between 4000 to 10 power 6. For the determination of coefficient of friction, first we are going to determine the Reynolds number. The formula for the determination of the Reynolds number, Re is equal to Re is equal to rho V d by mu. Rho V d by mu. Here rho is the density of the fluid, V is the velocity of flow, and d is the diameter of the pipe, and mu is the viscosity of the fluid. But density of the fluid, if the fluid is water, the density of the fluid is equal to 1000 kg per meter cube. But here in this problem, that fluid is not water, the fluid is having a specific gravity is 0.9. Therefore, first we are going to determine the density of the fluid, rho. Density of the fluid rho is equal to specific gravity of the fluid into density of the standard liquid into density of standard liquid. Density of standard liquid means density of water. Therefore, density of this given liquid equal to, what is the specific gravity? 0.9 into density of the standard liquid or density of the water is equal to 1000 kg per meter cube. Therefore, density of the given liquid is equal to 900 meter cube per second. Now we have determined here that is the density of the liquid. Then Reynolds number Re is equal to rho. What is the rho value? 900 into velocity of flow. Velocity of flow given? Velocity of flow not given, but they have given the discharge. First we are going to determine the velocity of flow. For that, we know one standard formula, Q is equal to A V, cross-sectional area into velocity, or V is equal to Q by A. Right. V is equal to Q by A. What is Q? Q is given 60 liters per second. That converts into meter cube per second. That's 60 into 10 power minus 3 meter cube per second. That Q value is equal to 60 into 10 power minus 3 meter cube per second divided by area. What is the area formula? Pi d square by 4. D is the diameter of the pipe. This is equal to 4 into 60 into 10 power minus 3 divided by pi into what is the diameter? In the problem, diameter is given, that is 200 mm, that is equal to 0.2 meters square. Therefore, velocity of the flow V is equal to 1.19 meter per second. Right? Velocity is unknown. For the determination of the Reynolds number, we should know the velocity. For that, we have determined the velocity by using the given discharge. Q is equal to AV, that is equal to V is equal to Q by A. Here Q is known to us and diameter also known to us. Based on these values, we have determined the velocity is equal to 1.19 meter per second. Right? Therefore, Re is equal to 900 density of the fluid into velocity is equal to 1.19 into diameter of the pipeline is equal to 0.2 meters divided by rho V D by nu, that is viscosity of the fluid given in the problem. This is in CGS system. Viscosity is given in CGS system, that is equal to 0.06 poise. Now this converts into SI system, that is Newton second per meter. Right? This is equal to 0.06 into 10 power minus 1 Newton second per meter. Viscosity of the fluid is given in poise, that is in SI system, that converts into, this is in CGS system, that is converts into SI system, that is equal to 0.06 into 10 power minus 1 Newton second per meter square. Right? The viscosity is equal to, right, this is the viscosity. That is equal to how much? Viscosity is equal to 0.06 into 10 power minus 1. Therefore, Reynolds number is equal to 57300. This is the 57300 is the Reynolds number value. This is dimensionless parameter. There is no unit. So Reynolds number is equal to 5700. Therefore, this Reynolds number value is in between 4000 to 10 power minus 6. So therefore, the coefficient of friction is determined by using this formula. Therefore, F is equal to 0.079 divided by Re power 1 by 4. 0.079 divided by what is the value of Re? Reynolds number is equal to 57300 whole power 1 by 4. Therefore, F is equal to 0.005. F we have determined here. In the standard formula, HF is equal to 4 FLV square by 2 GD. F is determined here. Velocity is also determined here. Right? Now we are going to substitute the values in the standard equation. What is the standard formula? HF is equal to 4 FLV square by 2 GD. Therefore, HF is equal to 4 into coefficient of friction, that is equal to 0.005 into what is the length? Length is given in the problem, that is equal to 500 meters. That is equal to 500 meters into what is the velocity? We have determined that is 1.19 meter per second. 1.19 divided by 2 into 9.81 G value into diameter of the pipe is also given in the problem, that is equal to 200 mm, that is equal to 0.2 meters. Finally, head loss due to friction, HF is equal to 9.48 meters. Here head loss due to friction, HF is equal to 9.48 meters. And one more question they have asked, that is what is the power required? Power required formula is equal to, power is equal to WQHF divided by 1000, HF divided by 1000 kilowatts. Power required equal to WQHF divided by 1000 kilowatts. Now W is nothing but what? Rho G. Unit weight is equal to mass density into acceleration due to gravity. Unit weight is equal to mass density into acceleration due to gravity, rho g into Q into HF divided by 1000. Now, what is the rho value we have determined? That is 900. 900 is the density into G value 9.81 into what is the Q? Q is given in the problem, that is 60 liters, so 60 into 10 power minus 3 meter cube per second. 60 into 10 power minus 3 meter cube per second into what is the HF? Head loss due to friction, 9.48 meters. 9.48 divided by 1000, we have power required is equal to 5.02 kilowatts. Power required is equal to 5.02 kilowatts. Right? In this problem, they have given specific gravity of the flowing liquid, viscosity given, diameter given, discharge given, what is the head loss due to friction, length of the pipe is also given, what is the power required. Right, we have taken basic formula, that is HF is equal to 4 FLV square by 2 GD. In this formula, F is not given, V is also not given directly. That F is nothing but coefficient of friction. Coefficient of friction is equal to F is equal to 16 by Reynolds number. If the Reynolds number is less than 2000, if the Reynolds number is in between 4000 to 10 power 6, the coefficient of friction F is equal to 0.079 divided by R power 1 power 4. Right? For this, first we are going to determine the Reynolds number. Reynolds number RE is equal to rho V d by nu. Rho is the density of the fluid, V is the velocity of the fluid, D is the diameter, mu is the viscosity of the fluid. Viscosity of the fluid given, that is equal to 0.06 poise. That converts into, this is the CGS system, that converts into SI system, 0.06 into 10 power minus 1 Newton second per meter square. Right? Now, density is the water, the flowing liquid is the water, automatical density is equal to 1000 kg per meter cube. But in this problem, the flowing liquid specific gravity is given. Based on that specific gravity, we are going to determine the density of the flowing liquid. Density of the flowing liquid is equal to specific gravity into density of the standard liquid. Specific gravity is given, that is 0.9, into density of the standard liquid, that is the water, is equal to 1000 kg per meter cube, that is equal to 900 meter cube per second. Right? Density is calculated, and velocity is also not given. Velocity is calculated by using standard formula. Q, discharge, is equal to area into cross-sectional area. V is equal to Q by A. V is equal to Q is given in the problem, that is 60 liters. That converts into meter cube per second. 60 into 10 power minus 3. 60 into 10 power minus 3 divided by area, pi d square by 4. Then D is also given in the problem, that is 200 mm, that is equal to 0.2 meters. All values are here. Substituting all the values here, finally we have velocity is equal to 1.19 meter per second. This velocity is substituted in the equation. Rho is equal to 900, velocity is equal to 1.19, diameter given 0.2 meters, so into viscosity is also given, that is 0.06 into 10 power minus 1. Finally, we have the Reynolds number is equal to 57300. Right, Reynolds number is in between 4000 to 10 power 6. Therefore, the friction, coefficient of friction is determined by using this formula. Therefore, F is equal to 0.079 divided by RE, Reynolds number whole for 1 by 4. Based on this formula, I have substituted the Reynolds number value here, that is equal to 57300. Finally, we have the Reynolds number value. Finally, we have the coefficient of friction is equal to 0.005. Coefficient of friction is known to us. Then we are going to substitute the values in the standard equation. 4 FLV square by 2 GD. 4 F is given 0.05 and L is given, that is 500 meters, and velocity, that is 1.19 divided by 2 G, 9.81, diameter 0.2. Finally, we have the head loss due to friction, that is equal to 9.48 meters. One more question they have asked, that what is the power required to maintain this flow. Power equal to, we know one standard formula, that is equal to WQHF divided by 1000, that is in kilowatts. W is nothing but rho, mass density into G, acceleration due to gravity, rho into G into Q into HF. Rho is nothing but, already we have determined here, 900 into G is equal to 9.81. Q is that is given in the problem, 60, that 60 into 10 power minus 3 meter cube per second, 60 into 10 power minus 3 into HF, head loss due to friction, already we have determined here, that is equal to 9.48 meters. Divided by 1000, we have power required to maintain the flow. Power required to maintain the flow is equal to 5.02 kilowatts. Right? These are the problems related to head loss due to friction or major head loss. Right. Thank you one and all.